This is Nolan Arba, the first human being to receive Elon Musk's Neuralink brain implant. Let's talk about how Neuralink technology has already begun to change the world. In a surprise live stream through the X platform, Neuralink introduced the world to their very first human patient, Nolan Arba. With his personal Neuralink engineer holding the camera, the man who we've all been speculating about for the past 2 months finally got the opportunity to tell his own story. Nolan is 29 years old and has spent the past 8 years living as a quadriplegic after a diving accident dislocated his C4 and C5 vertebrae. These are bones kind of right in the middle of the neck, halfway between your collarbone and the base of your skull. As a result, Nolan has no sensation or control of his body from his shoulders down, but that hasn't stopped him from remaining incredibly positive about his life, and now thanks to Neuralink, it isn't stopping him from playing video games either. Nolan currently has Neuralink's N1 brain-computer interface chip implanted underneath his scalp and sitting flush with the bone of his skull. Underneath that chip are 64 tiny wires that have been placed into the surface of his brain about 2 millimeters in depth and specifically targeting the motor cortex region. This device allows Nolan's brainwaves to be translated into digital command prompts. So the first demonstration that we get is seeing Nolan play a game of virtual chess, and it's indistinguishable from a person using a computer mouse. Nolan hits pause on the background music, he moves the cursor around the screen quickly and smoothly in a way that seems effortless. Prior to the implant, Nolan would have to use a mouse stick to control his laptop. Now he is using a Bluetooth signal that transmits from a small computer chip in his skull directly to his device. Nolan explains the process of learning to use his Neuralink, and this was a learning experience for everyone because the engineers who have been developing this product for nearly a decade have never been able to hear feedback on what it's like to actually use their device. They can make an educated guess about what's going on inside the mind of a monkey, but having a human subject that you can actually dialogue with back and forth is such a massive upgrade. There were 2 approaches that Nolan worked on with the team: attempted movement versus imagined movement. Attempted movement was focused on trying to move his hand to move the mouse, the way that he would have done before he was injured. The idea being that even though his spine is broken, the neural pathways associated with movement are still intact and can be used as triggers for device control. Then there's imagined movement, and according to Nolan, this quickly became the most intuitive way to use his Neuralink ability. All he has to do is imagine the cursor moving, like using the force to move an object. He just looks at the area on the screen, and the cursor goes where he wants it to. And you can tell how effortless this is because as Nolan is talking to his Neuralink engineer and to the camera, he is also continuing to play chess at the same time. So he can already multitask between physical activity and Neuralink activity. And Nolan has only had his implant since January 28th. Obviously, the tech side of things is really cool, but what really sticks with you is just how much of a positive benefit this technology has already had on Nolan's life. He talks about how he was able to stay up all night playing a video game for the first time in years, something that any of us would take for granted. But Nolan was only able to use devices like his computer and iPad while sitting in his chair, and while in a sitting position, he needs constant care to readjust his weight and make sure that he won't develop pressure sores. The wireless connection in the Neuralink allows him to work and play while laying down in his bed where he can stay unattended for hours at a time. This gives him back a level of independence that would not have been possible without the implant. We'll just let Nolan describe his new life in his own words. Listen to this.
It's crazy. It really is. It's so cool. I'm so freaking lucky to be a part of this and stuff. I mean, every day it seems like we're learning new stuff, and I just can't even describe how cool it is to be able to do this.
As far as the downsides to his procedure, Nolan says that the biggest limitation is dealing with battery life. As we expected, the Neuralink chip can run for 8 hours on a single charge. Then Nolan says that he has to wait for the device to recharge until he can use it again. Now, we know that Neuralink isn't letting patients use the device and charge it at the same time, and that makes sense. They don't want to risk the implant getting too hot. They probably aren't using fast charging either for the same reason. As far as the implant procedure is concerned, again, Nolan was very positive about his experience. He says that the surgery was super easy, and he was released from hospital later on the same day. He also mentioned that he has not experienced any cognitive impairments since getting his Neuralink implant. Nolan might be the first human Neuralink user, but he definitely won't be the last. For all we know, there could be more people like him already. In September last year, Neuralink announced that they had started recruiting for the first human test subjects for the N1 brain-computer interface and R1 surgical robot that will be used to implant it. The PRIME study, short for Precise Robotically Implanted Brain-Computer Interface, aims to, above all, determine the safety of both the implant and the robot for human application. It will also assess the initial functionality of the N1 in enabling people with paralysis to control external devices with their thoughts. It's expected that the first human trial will take up to 6 years for Neuralink to complete and verify their findings. The primary study period will take place over the first 18 months after the device has been implanted. Patients will check in with a medical team every 2 months to monitor progress and ensure the Neuralink device continues to work as intended. 1-hour BCI research sessions with the Neuralink team will be completed at least 2 times per week for every patient for the duration of the 18-month primary study. In 2021, Neuralink performed a total of 155 surgeries on sheep, pigs, and monkeys. In 2022, that number grew to 294 total surgeries. In a typical FDA human trial, the medical company would be limited to just 1 human experiment in the first year, with a long cooldown period to assess the results. But in the case of Neuralink, thanks to their existing track record with animal testing and the massive outpouring of interest from prospective human patients, the company has already received a green light for multiple human surgeries in 2024. The plan right now for Neuralink is to perform 11 human implants in 2024. That will increase to another 27 implants in 2025 and 79 in 2026. If all goes well, after this point, operations at Neuralink will begin to truly ramp up. The company anticipates 499 surgeries in 2027, and then exponential growth into 2030 when they are performing 22,204 surgeries in that year. Yes, 22,000. That was not a typo, but it is a very ambitious goal. Let's take a minute to consider the results that we've seen so far and talk about this in the context of the BCI world. Cursor control, like we've just seen Nolan perform, is not a new development in the field. This has been possible for decades now. However, the ability of a patient to do this wirelessly in the comfort of their own bed with no hardware or wires sticking out of their head, with no external help, that is special. There are only a small few devices that can accomplish this, and Neuralink has become one of them. Neuralink is also an exceptionally invasive procedure. This is a big deal. There is literally a hole in the patient's head and a computer underneath their skin. It shouldn't be lost on anyone that patients like Nolan are taking an incredible risk. He's a remarkably upbeat and positive person, but he's also very brave because he'll also be the first to experience the long-term effects of the procedure, whatever they might be. This is a known unknown. But the reason he's doing this, or anyone in the initial study is doing this, is because the potential upside is worth the risk. Right now, we are not seeing Neuralink doing anything that hasn't been done before with BCI, but we are also seeing less than 1% of the capability of the Neuralink device being used. Even for a very similar modern BCI implant, cursor control is about the best they will ever accomplish, which is still amazing and perfectly valid, but due to the invasive nature of the implant and the level of engineering and innovation that we've already seen from Neuralink, we know that Neuralink has the potential to do things that have never been done before. Restore eyesight to the blind, return physical movement to the paralyzed, reverse degenerative brain disease. We don't actually know what the upper limit of the hardware even is. Neuralink has promised to continue telling the story of Nolan and their first human study. There will be amazing things to come that people would have never believed possible. There could also be tragedy. This is only the beginning of the beginning.